When you look east from St. Helena Island in Beaufort County, South Carolina, you are looking at an area of marsh and islands covering more than 30,000 acres. Those marshes appear to have been there forever, but 5,000 years ago, those marshes and islands did not exist, and instead, the Atlantic Ocean lapped against St. Helena Island's eastern shore. Over time, as sea level rose and fell, new islands formed, marshes grew behind them, and with each passing century, the ocean shoreline moved farther east toward where it is today, 5 miles east of St. Helena Island. Native Americans moved onto the newly formed islands and harvested the fish and shellfish in the tidal creeks. For many generations, these people's daily lives were closely tied to the coast tidal rhythms, and their canoes carried them wherever they needed to travel to harvest the marsh's abundance. Evidence of their presence is found in the numerous shell heaps that dot the islands and hammocks. With time, the Native Americans moved out of these marshes, and they were replaced by Europeans and Africans. All of these early residents realized that the coast is a dynamic environment. They watched as beaches eroded and as undermined trees collapsed into creeks and tidal channels changed course, and they accepted those changes as part of the natural course of things. Today, as we invest more in docks and seawalls and larger, more permanent houses, the ever-changing coastline is a major threat to a way of life. With sea level rising as a result of global warming, present-day residents will have to adapt to the coast's dynamism, just as its past residents did. Through the study of coastal geology and archaeology, we can chart the history of the St. Helena marshes, and through understanding that past, we can better anticipate the future of coastal environments here and elsewhere. Well, about 18 months ago, I got a phone call from a fellow named Gibbs McDowell who lives down here in the Beaufort area and has a cabin out on one of the small islands in the marsh east of St. Helena Island where we are today. And he had found some shell on some of his islands and seen Indian pottery, and he just wanted to know if there was any way to tell how old his islands were. And so I have a lot of experience in doing that kind of work from the Georgia coast, and it just happened that he called probably one of the few people in the world that could have answered his question, and that being me, based on my background in Indian sites and work with sea level change and shoreline development on the Georgia coast. So we talked for about an hour in that first conversation and figured out that we had a lot of common interest, and within a couple weeks I was down here running around in the boat with him out in the marsh and looking at all the shell middens that he'd seen. And we decided that trying to work in this whole St. Helena Marsh area over the next few years would be the kind of project we both wanted to get involved in. And so that's what we're doing today. These are the first excavations we're going to undertake later today on one of these shell middens, and then over the next couple of years we'll be doing lots more of those kinds of excavations and understanding the Indian occupation here in more detail as time goes on.
In the early 90s, some friends and I bought a little island with a fish camp on it, and we wanted to renovate it and have it for recreational purposes and a nice place for our kids to come and learn to fish and crab and enjoy the low country outdoors. And while we were working on it and digging post holes, we were coming up with old oyster shells and pieces of pottery, and had nice decorations on it and several different types of it. And we were curious as to how old the pottery was and what Indians would have left it there and when. And being a USC history major myself, I got curious and thought there's got to be somebody I can find that can help me figure this out. And I called around locally, and they suggested there would probably be someone up in Columbia, at the University of South Carolina, that could help me out. And coincidence would have it, the first phone call I made, Dr. Chester DePratter picked up the phone at the archaeology department, and I told him who I was and what I was interested in. And coincidentally, again, he had a map of Beaufort County on his desk at the very moment, looking for another project to get into. And so all the stars lined up. I told him what I wanted, and he asked when he might come down and look at the islands and the pottery. And I said, well, what are you doing tomorrow? And he said, I guess I'll be in Beaufort. So he packed his stuff and came down, and sight unseen, we spent the weekend at the camp. And we ate fresh crabs and steamed shrimp and oysters and caught a few bass and did island hopping and exploring. And before the weekend was done, we had a project underway. If you open Webster's dictionary for professor, Chester's picture would be in there. Compact, energetic, whiskery, very passionate about what he does, and low-key and personal. He's a really neat guy. He's the full package. Easy to work with. You know, I was dumb as dirt when it comes to what we were looking at, and he really, you know, took me under his wing and educated me as to what we were doing and what was relevant and how to understand what it was we were looking at. I'd been walking on these islands, on these shell piles my whole life. I'm 52 years old, and I thought it was just piles. Very educational. He would find a spot that looked like absolutely nothing, bring out his little Indiana Jones trowel, and ipso facto, he'd come up with a piece of pottery or an arrowhead or something like that. I said, this is neat. We've got to do this.
Well, the first time I came down to work with Gibbs, he took me on a boat tour of most of the places that he had already identified as Indian sites. Many of them were on his own little islands that he owns around his cabin. So we went out and looked at 6 or 8 different places. His cabin sits on top of a shell midden that's about 1,000 years old. And so you can walk around in his yard and pick up pieces of pottery, and he's got some of those up on the windowsill in his house to show people. And he'd already collected those, so he knew that they were Indian, there was an Indian site there. He didn't have any idea of his age, so that was our first stop, and right away he knew he was sitting on a 1,000-year-old Indian village there. Once I had toured the marsh with Gibbs and had seen the shell middens that he knew about, we began to look for additional sites that would help us understand the Indian occupations and the processes involved in the development of the St. Helena marshes and islands. Some of the sites we ultimately visited, we first identified on aerial photographs, where they were readily identifiable. Others we spotted while flying low over the marsh in a helicopter used in filming for this project. But most we found by visiting small islands and hammocks by boat. On each hammock, we searched along the exposed margins for shellfish remains and pottery. When we found a place where the Indians had lived, we made notes about the size and depth of the shell deposits, and we collected a sample of pottery to help date the midden. Because we are interested in past sea level change, we probed around each shell exposure to find additional shell that had been buried beneath the marsh due to rising sea level. We have not completed this survey part of our project, but to date we have identified more than 50 prehistoric Indian sites that span the period between 4,000 years ago and 500 years ago. Ultimately, the locations of these sites will allow us to track the eastward progression of the shoreline across the St. Helena marshes.
Yeah.
We're standing on a several thousand-year-old Indian shell pile, shell midden, shell ring that a good friend of mine, Mr. Joe Mix, who owns Fruit Plantation behind us, told me about. I was sort of sharing my excitement with him over lunch one day about all the island hopping Dr. DePratter and I have been doing, trying to locate these some 70-odd Indian sites we found on these little barrier islands out here. And he got all animated and excited about it and said, well, he thinks he's got one of those right behind his house. So we came out one afternoon and shook hands and walked out here, and lo and behold, here we are. It's a shell ring that's some several hundred feet long and a big sweeping arc.
Well, this pile of shell we're standing on is a 3,000 to 4,000 year old midden, where the Indians lived here that long ago and threw their waste out around them, made this large pile of shell that from what we see at the surface is predominantly oyster. But mixed in with it is all kinds of other shellfish and bones and other trash. And we know how old it is because of the pottery that we find here on the surface. So the pottery here, which is around 3,000 to 4,000 years old, is some right here, is the way we can tell approximately how old it is. One of the things we'll do while we're here is take some carbon samples, probably shell, and then get those processed, and it'll give us more precise age to tell us exactly how old it is within that 3,000 to 4,000 year old range. So this one's been stepped on and broken, and this is actually perhaps a piece of later pottery that's here on the surface, but we won't know for sure. Nope, it's got fibers in it. So the way we tell that this site is 3,000 to 4,000 years old is this pottery is called fiber tempered pottery, and mixed in with the clay that they used in manufacturing the pot are fibers, either Spanish moss or palmetto fibers. And then when they fired it, the fibers burn out and leave these distinctive little tracks in the surface of the clay. And so we call it fiber tempered pottery or Stallings period pottery, and we know its age from where it's been found in other sites and excavated and dated there. And so it gives an approximate range for the age of this site. It's about 3,000 to 4,000 years old, and once we get radiocarbon dates on it, we'll know precisely how old it is within that range. What we're trying to map on this back edge is whether this shell that we see exposed is sitting on the original land surface, or whether part of the site has been covered up by marsh as sea level rose up and flooded the fringes. And so that's why we're using the probe out here to see if there's buried shell that dips down underneath the marsh surface. Ultimately, if we come back, we'll dig back here on that old land surface and we'll probably find broken pottery and garbage of the people that lived here. But right now it's covered up by marsh and we're just mapping the edge of the shell. Yeah, the way we map a site like this is we find magnetic north, orient the transit over a point that we've just chosen arbitrarily to start with. Once we know where magnetic north is and we've got the transit set up over this point, we can just turn an angle and set up in another point, like the one up there with the flag sitting by it. We know where that angle is relative to magnetic north. We know what the distance is, so we can draw that point relative to this, and then we put in another one back down this way the same way at a known angle and a known distance. And then from these points in, we can set up at any of these and shoot points along the edge of the midden, on top of the midden, and make a map of the whole site relative to these 3 points. We put in these reference points so that we know exactly what the site looks like, so when we come back and dig, we can know exactly where we're digging on the site and map that in relative to these points. And then, you know, we could dig this year in one hole and come back 10 years from now and dig the square right next to it with some precision. And so you're never overlapping, you're never digging in parts of it that have already been dug. And that allows us to track precisely what we're finding, where we find it. And when we get radiocarbon dates, we can tell what's associated with, rather than just coming out and digging a hole and not knowing where we're at or what we're finding or how it relates to anything else. Okay. Well, what we're looking at right down here on the ground is a pile of periwinkle shells. These are little kind of snails, univalves, that feed on the algae that grows on the marsh grass out here in the marsh behind us. The Indians would have gathered those up and boiled them and made a broth of them and perhaps a stew with other things in it. And then once they were finished with it, they just dumped those shells out here on the ground in this little pile. So what we're looking at here has been here at least 3,000 and maybe 3,500 years, evidence of a single meal from that time period long ago. I've never eaten periwinkles. They have lots of parasites in them that you have to be real careful about, but I hear they're tasty. We're out here in this crescent-shaped shell midden in the marsh, digging some small holes to get samples of shell for radiocarbon dating. Normally we would be pumping water out of the marsh to remove this really sticky muck that's surrounding all the shells and the artifacts, but today we're just digging these small holes in order to get shells for dating, so we're just not bothering with that right now. When we come back and do major excavations, and of course we will, move much more carefully and use water and wash all of this stuff off so we could see what's in here, collect all the bones and pieces of pottery and those kinds of things. But for right now, we're just going to get down about 40 centimeters, about a foot or a little bit over, to get the undisturbed shell that we need to date the whole site. We've dug 3 holes so far, or this is the third, because we want to get samples from along the entire ridge, which is about it's a foot or two high and about 300 feet long. So we need samples from various parts of it so we can make sure we've got the entire age of the site represented in the samples we take. I've excavated lots of these shell middens on the Georgia coast, but this is the beginning of this project up here in the marshes at St. Helena Island, because I've only been doing this for a little while. In the initial phases, we're finding sites, and now we're getting to the point where we're ready to start digging and recovering data and dating sites and begin looking at the shoreline positions based on the ages of these various shell middens. And so really this is just the beginning of what we hope to do here, and these carbon dates will give us a baseline to work out from as we move east toward the more and more recent shorelines. The sites up here in South Carolina and the marshes of St. Helena where we're working are pretty much like the ones I've spent the last 35 years working on the Georgia coast. My focus has been on the sites out here in the marsh because I'm real interested in sea level change and development of shorelines and the Indian occupation of those through time. Go ahead, Mike, throw something in. And so what we're doing here is really an extension of the work I did back on the Georgia coast in the 70s and 80s, and I'm glad to be able to get back and do it, because here there's even more sites, it seems, and they're undisturbed and have the potential for contributing a great deal of information. It's important right now as sea level is beginning to rise again because of global warming. So what the sites we're seeing out here in the island formations we're working on are the result of sea level change when sea level rose and fell over the last 4,000 years. And so now we're tracking that through archaeology of that age, and it'll give us some idea of what's going to happen in the future when sea level rises another meter or 2 meters or more in the next couple centuries. So a lot of the places we're working are going to be underwater in pretty short order. So we'll track that change through time in the past and use it to help us understand what's going to happen in the future as sea level rises again. Oh, here you go, Mike. It's a piece of pottery. Actually, I'm not sure what it is. It's got 2 parallel sides. It's not broken. I'll have to wash it off to even see what it is. Fortunately, we have water right here. I'm just going to sit down. It is a piece of pottery. It's just got a smooth edge on it. It's not fiber tempered, Mike. It's some kind of sand temperature.
Sweet.
Mr. Mix provided funds to date 2 shell samples from the site on his property. Those dates indicate that the site was occupied between 4,100 and 2,300 years ago.
Looks like I got some old stuff and some
Modern stuff too.
modern stuff.
It's not very old at all. That's 19th century. And this one is certainly Indian. Tom's Creek shirt, around 3,000, 3,500 years old. So
Wow.
it's just like the other site down there on the way.
Okay.
Is it a big pile of shell?
Well, I never made it to the new place. I made it to the second new place. There's a big creek back there.
Oh, that's right. You see that on the air photo. I forgot
Right.
to tell you about that.
I've got long legs, but they aren't that long.
But this is on the way there? There's another pile of shell out there?
The second pile you'd seen from the satellite photograph right down here.
Although there are many Tom's Creek sites in the St. Helena marshes, the Spanish Mount site on Edisto Island, 15 miles farther north, provided an excellent opportunity to date and better understand coastal occupation during this time period. Well, this is a 3,000 to 4,000 year old shell midden here at Edisto Island State Park. We're here because this has eroded away in the past few hundred years, and now we're trying to record what's left before the rest of it tumbles into the marsh. So we've got a pretty big job here ahead of us. You can see the part we're recording is about 30 meters long, or close to 100 feet, and it's about 2 meters high, so that's about 6.5 feet. And we're trying to record all the detailed strata or layers that are in there that tell us about how the site was formed through people living on it, we believe, and try to figure out the age of the different levels within it. So if you come back this way, you can see that there's a lot of evidence of these different occupation zones, we call them. Some places you can see, like right here, there's just clean shell, and that's just a shell dump from a meal or for a short period of time. But then there are all these other layers that are here with dark soil and crushed up fine shell you can see down in here, and those are surfaces that people walked on. And there was time for debris to accumulate, organic material, leaves, branches, garbage of various kinds. And then people might have used that surface and lived on it for a while. And then there's another layer of clean shell where this particular area was just garbage. And then right here you can see there's another occupation layer. And so what we're doing is we're recording all those different layers in here and looking at it from bottom to top to see if we can plot the surfaces that people lived on through time. And then we're going to come back, and along this whole profile, as we call it, we're going to take 10 or 12 or 15 samples of shell and have those dated by radiocarbon method and see if we can't tell when it was established and then when it was abandoned, and then within it, along its length, when these different occupation zones were put in there. It's very you can see it's very friable surface, so you just touch it and it collapses, and the sand down underneath is so soft that the reason this has gone away so rapidly due to erosion is whenever there's a storm, it used to lap away at the bottom of this midden, cut into the sand, and then all of this shell would collapse from the weight pressing down on the undercut sand. So we believe here we've lost perhaps hundreds of feet of shell. It used to go out toward the marsh here behind us, and now it's eroded back to the point where there's only a small remnant left. And when I saw this about a month ago, I realized that it was critically important to come and record what's left before it's reached the point where there's nothing here that's worth salvaging. These orange flags are just marking places where there were pieces of pottery that we saw when we started looking at this profile in the beginning. And we're keeping track of where they are because we want to know where in the occupation these pieces of pottery fall. So if you look over here, we've got the pieces of pottery that were pulled out at that point, and those are flags number 2 and 3, so this is the pottery that came out of those places. And as you can see, they're decorated. And so that means that in the occupation of the shell midden, there was decorated pottery all the way to the bottom. Well, these pieces of pottery are pretty typical of the kinds of materials we find on the Georgia, South Carolina coast over all of prehistory. And we recognize a number of different types by the different texture of the clays and the inclusions that the Indians put in there, sometimes fibers, like in this case, you can see the little fiber impressions in here. And this is recognized as the oldest kind of pottery in the southeastern United States and actually in all of North America. It's called Stallings pottery these days, and it has these distinctive fibers in it. This particular case has these grooves in it where the Indians actually made bone tools. So they took a splinter of deer bone and rubbed it back and forth in here and created bone pens about the diameter of this pencil and about 8 or 10 inches long that they used for purposes not totally known, maybe for making baskets, maybe for holding deer skins together or whatever. But this is the earliest kind of pottery, and it dates around 3,000 to 4,200 years ago. Also at about the same time, there's this other kind of pottery that we find called Tom's Creek. Tom's Creek comes from a place in the interior of South Carolina near Columbia where this kind of pottery was found and identified for the first time. And this is decorated with tools of different kinds. This one looks like just a splinter of bone that was used to make these little indentations or punctations in the surface you see here. And another piece of the same time period where they took the same tool and made a series of closely spaced little punctations in the surface in zones, so it doesn't go all over the pot. There's blank spaces and places that it's been punctated. And this has sand mixed in with the clay and doesn't have any of the fibers that you see on the earlier stallings. All of these pieces of pottery, we use type names that we call them that came from the place where they were first dug up. So Tom's Creek, as I said, is in the interior of South Carolina. Stallings Island is on the Savannah River up near Augusta. And then these other types are mostly from down around Savannah. So that Wilmington is named after Wilmington Island near Savannah. It's distinctive for its cord impressions on the surface where they took pieces of string or cord, wrapped them around a paddle, and then stamped them into the surface. And it has little distinctive lumps of clay mixed into the fabric of the pot. So that's pretty easily recognized when you get that. Later on, they started carving designs into the paddles that they stamped onto the pots. And so actually one of the earliest ones that we have out here is this one called Deptford check stamped. Deptford coming from Deptford Bluff near Savannah. And they actually took a flat piece of wood like a board and just carved lines on it at right angles, and then when you stamp that in there, you get a checkerboard pattern like this. And so that's Deptford check stamped, and that starts being made a few hundred years BC and goes on up to 500 or 600 years AD. As time went on, the designs that were carved on these paddles became more intricate, and so by the time you get to something called Irene, which starts being made around 750, 800 years ago, you get very fine line, very detailed patterns carved on these pieces of pottery, on these paddles that are then stamped into the pots. And this is fairly thin wall piece of pottery, as you can see, and it's got small bits of gravel or grit, as we call it in archaeology, and those give a lot of strength to the pot. They allow the clay to expand and contract when it's used for cooking. There's sometimes layers at the bottom that have only plain pottery, and then they developed decorated pottery during the occupation of the midden. But what we'll do now, we'll have good radiocarbon dates that go with this kind of decoration once we finish drawing our profile and get the radiocarbon samples run, and we'll know exactly the age of this pottery. 10 samples of oyster shells from various places in the Edisto Island shell midden were sent to radiocarbon dating lab in Miami, Florida for processing.
This area here, the pre-treatment is done of the samples. Depending on the actual sample material, there's various methods that would be used to clean things. For Dr. DePratter's shell samples, what would have been done is the samples would have been given a light etching on some weak acid to remove the outer surface so that we would be able to work with clean, fresh shell and remove any outer surface dirt or potential secondary carbonate that may have accumulated on the sample while it was buried. After that, the samples would then be placed into a drying oven and they would be dried down.
In a series of complex procedures, the samples are processed to concentrate the carbon atoms present in the shell. This involves crushing the samples, mixing them with phosphoric acid, and then collecting the carbon dioxide gas that is given off. A catalyst is then added to form the benzene that is needed for the next step in the process. The laboratory is kept scrupulously clean in order to avoid any potential of contamination of the samples.
Well, we are now in our liquid scintillation counter room. This is where the measurements are made on our final product, which is liquid benzene. They're loaded into these counters, and we're able to make a measurement. In this particular counter, we have one of Dr. DePratter's samples is actually being measured right now. What this machine allows us to do is to actually measure the carbon-14 beta decays that are occurring. Only 1 in a trillion carbon atoms is a carbon-14 atom, and that is why we needed to try to concentrate our carbon down into this final product, which is benzene. That gives us the most amount of carbon in a small space as possible. So we are now counting these samples in here, so we're actually able to measure the number of decays that are occurring over 1 day, 2 days, 3 days amount of time, however long it may take us to get ourselves enough counts to come up to generate an age that will allow us to give the person a good standard deviation, or plus or minus, associated with that age. In order for carbon-14 to work, we work with the assumption everything that is alive, humans, organisms, are taking in carbon, and therefore carbon-14 while they're alive. Once the organism or the person dies, the amount of the carbon-14 stops being taken into their system, and it starts to decay away, and we start to have lower and lower levels. The half-life of carbon-14 is about 5,700 years. That allows us then to have an equation that can be plotted into a computer. We can measure how many counts we saw in Dr. DePratter's sample. We know how much of the sample we had. We can plug it into a known equation that takes into account the half-life of carbon-14, and we are then able to establish how old the samples are.
The 10 dated samples from the Edisto Island site range between 3,500 and 4,000 years in age, indicating that this Toms Creek period shell midden was deposited over a span of about 500 years. With work on the eroding Edisto Island shell midden completed, we again turned our attention to the many archaeological sites and geological features in the St. Helena marshes. We're sitting here waiting for a couple of geologists going to be working for us for the next few days, trying to help us figure out a little bit about the geology of these coastal islands and hammocks that we're looking at here in St. Helena marshes. They're basically geological features that have been shaped over the last 4,000 or 5,000 years, and while I'm an archaeologist and can go out and collect archaeological materials and try to provide dates for them, the geologists will tell us about the origin of the islands and how they've been changed through time by erosion and deposition. So really excited about having them come in here and work with us. Oh, here they are right now.
Howdy.
Hello.
Hello. Grab that stern line there for us.
Yeah, we got it.
Put your hands. Don't want any broken geologists before we get started here.
Hey, Chester. Joe Donahue.
Nice to see you.
How are you?
Frank? Good
Frank
to meet you.
Stafer.
Nice
Good to meet you,
finally.
Chester.
Come on aboard.
Take her easy there.
Pretty place.
Right.
Oh yeah, this is Johnson Creek Camp. This will be our home for the next couple of days. I think you guys will enjoy it. Come on
Looks
up.
great.
Watch your
Just
step.
turn around.
Two at a time on the ramp, unless you want to go mud bobbing.
I've got a map here I want to show you so we can get ourselves oriented and figure out where we're going to do some sampling in the next day or two.
Good.
This is a color infrared composite. Gives a little detail of the area here. Obviously this is the marshes where we're going to be working, and the landing you came in from is over here. We're out on this little hammock right here that's Gibbs's camp, and so we're going to be operating out of here for the next few days, and then we got this whole sweep to visit. We've got permission to go down here to this island complex, and a lot of this is state land in here, so we have access, and this is obviously Hunting Island State Park, so we've got pretty much free reign over this whole area. So I thought I'd leave it pretty much up to you where we wanted to go, since we're here primarily to get the sampling for the geology rather than the archaeology that I focus on.
I'm most interested in getting some samples here on Old Island, based on my previous work 30 years ago that led me to believe that this has the potential for being a very old island.
No pun intended.
No pun intended. And
Where's
I've got some detailed sampling sites laid out on this detailed photograph. And Gibbs, how can we get easiest to this inside bend here of the island, which is right in here?
Well, we're back here behind Hunting Island, and we're going to have to come all the way through Harbor River back up into Fripp Inlet, and then come up Old House Creek all the way to the back side of the island. And there's a few small tributaries in here We've got a rising tide this morning, so we can't get stuck.
We traveled to Old or Story Island by boat, but we decided to walk across the island to our sampling site due to tidal issues and so that we could take a look at the many old beach ridges that reflect the island's history. Yeah, maybe that's that other island back behind there we're looking. So this may be the last ridge.
Yeah, I think it is.
Yeah, this is it then. Yep, you're right.
We are right where we want to be.
So what's it going to take to sample it?
Collecting a sample through this dune ridge, which is more or less perpendicular to the beach ridges that we've been sampling, the one that we sampled earlier. And again, it's a sample of the dune sand for optically stimulated luminescence dating, OSL dating, where we collect the sand essentially in the dark. So we've got an opaque tube we're pounding into the side of the dune in an excavation that we've just opened up. So since the time that the dune was deposited, that sand hasn't been exposed to light. So this method measures the time of last exposure to light. In other words, this sand here, if we took it to the lab and did a luminescence date, it should produce a zero age. That's what we would expect. So I'm calling this 10/15/06/02.
So is that saying when you take that core sample out of the center, is that taken out in a dark room or
Yeah, when we
special circumstance?
when we take it to the lab, it's opened up under essentially dark room light. It's red light, like a red number 2 light, like it used to develop photographs. And anytime it's exposed to light, it's under that dim light. So the whole process is done either in the dark or under dark room light. The reason being that the process involves exposing this sand in a machine called a RISO reader, a TL luminescence reader, to a specific wavelength of light, in this case laser light actually, green laser, and looking at the luminescence that comes off. So the luminescence can be quantified in terms of essentially the flow of electrons, the intensity of electrons that come off at a specific wavelength. And that amount is a function of the time that it has sat here in the dark and the amount of ambient radiation in these sands.
You can always use
Bumper.
bumpers.
In order to understand how the St. Helena marshes and islands formed, we will need many OSL dates and an array of archaeological sites that can be used for dating particular landforms. Once we have enough sampling points, we can begin to trace old shorelines and document sea level fluctuations that have occurred over the past 5,000 years. Our St. Helena research area is 16 miles long and 5 miles wide. Access to the sites we want to visit is almost entirely by boat, so tides must be considered in scheduling trips and in visiting targeted places in the marsh. Maps and aerial photographs are critically important to both spotting shell middens in the marsh and in finding tidal creeks that can be used to reach them. Given limited project funds, we have had to carefully select sites to visit and localities for OSL dating to maximize the amount of information collected in the short windows of research time available to us. This has sometimes meant slogging through waist-deep water or pushing the grounded boat off of a sandbar, but that is all part of the adventure of working in the marshes. Yeah, the tide will start dropping soon.
Wonderful locality for cross-checking our dating techniques.
Well, this is a little arc of shell. Oh, here's a piece of pottery before we go any farther. Kind of eroded, so hard to tell what it is. But this is a little arc of shell out here in the marshes closest to St. Helena Island. It's on one of the oldest ridges that's out here in the marsh. And we're interested in it because if we can get it dated, it'll tell us a little bit about the time when these first ridges formed and marshes were able to form to the west of them, so that the Indians that lived out on this ridge would have had access to all the marsh resources, the oysters and clams that you see scattered here on the surface, because they couldn't have lived out here unless there was a marsh nearby for them to gather those resources from. So over in the high ground behind me, there's a geologist right now, Frank Staper, who's taking a core, will get dated, and it'll give us an age of this island that we're standing on, so we can begin to understand exactly where the Indians lived relative to the coastline and to the marsh resources that they were dependent on. So we'll get a little bit of pottery off of here that'll give us a general date, and then we're hoping that the geological work will give us a more precise date for this, what turns out to be a crescent-shaped deposit of shell, occupied 3,000 to 4,000 years ago. Our next stop was St. Philip's Island at the southern end of the St. Helena marshes. This island consists of closely packed bundles of old beach ridges, and that makes it an ideal place to track depositional history. The Indians left shell refuse deposits on these ridges as the island developed, and once we have visited and worked on each of these shell middens and obtained enough OSL dates, we will be able to tell just how and when this island formed.
Walk across.
Would there be less marsh going across this way?
It might be easier to get to from the Trumpet Beach. You're going to have about the same amount of marsh either way. See, our road comes in through here, and then what there is, you want to ride down the road and I'll show you what we had to cross?
Sure. This beach on St. Philip's Island is now covered with fallen trees, and that's in part because of the normal process of erosion and deposition that takes place in these marshes and coastal areas that we're working on. Over a period of time, the coastline cuts back, redeposits sand elsewhere, then comes back sometimes and builds back where it cut off the beaches and the trees just 100 years before. So what we're seeing here is evidence of that in all of these fallen trees, but it's the kind of thing that we might see more and more of with rising sea level as the ocean level comes up and begins cutting back into these old islands, and it's going to be cutting away perhaps large areas before it stabilizes. Is that good? Oh yeah.
There's one between your feet there too, Boogie.
It's a little bit different. So okay if we take a sample of this?
You can take anything you like.
All right, we'll just keep it and I'll wash it up, and then I'll send you a little report on exactly what it is with some photographs. And
That'd be great.
Here's a pot lip.
oh yeah, now that's late. That's Irene. This is only about maybe 500 years old. This is a later kind than all this other stuff we're looking at. Piece of bone came probably. Yeah, that came out, probably goes with the pottery. It's like what it looks like after it's weathered in the soil for a while. You see?
Oh yeah.
Actually, it's an arrowhead, not a spear point. Stone projectile points and tools are rare finds in coastal shell sites. We know from the animal bones and the shell middens that the Indians were hunters, but they had few stone points. They would have used projectile points made from antler or bone to supplement their sparse assemblage of stone points. The small triangular point we found on St. Philip's Beach is typical of the small points that would have been used on the coast and farther inland during the late prehistoric and early historic periods. The tan chert from which it is made was obtained through trade from quarries around Allendale on the Savannah River.
This is telling me that this was an old beach, this chocolate-covered or mocha-covered material, and we're seeing the internal beach layering that people run around on the surface of the beach. These are each individual little layers of beach sand. This is where we're going to take a sample for our OSL dating. OSL dating of this material will give us a good cross-check on the dates that Chester has come up with for the pottery of 1000 to 1500. So this is best of both possible worlds for us geologists and archaeologists. We've got deposits that we can use now to cross-check each other's technique.
Results of the OSL dating are not all available yet, but so far it appears that they correlate well with my age estimates based on dating of archaeological collections. From St. Philip's Island, we moved on to a place known as Spanish Wells.
We're on a little hummock on the backside of Story Island near Trunkard's Inlet. And this strange looking washout in here has always been known by locals as the old Spanish Well. It was storied that Spanish galleons would pull into the sound and they'd row their longboats back up in here and fill their water kegs with water. And that's just what some of the locals always heard it called. And as a teenager, this place would flow water when we had wet winters. My father-in-law, who's now 80, says it used to run spring water when he was a teenager.
But all these shell middens that are here are down in the channel itself, so I think that, you know, it means that the channel was flowing when the Indians came here and occupied it. And the pottery that comes out of these shell middens is Wilmington. So, you know, it's at least 1,000 years old and maybe 1,500 or more.
Are the middens on this island localized along this?
No, they're all over the island. But this is apparently where the water gurgled up. Water pumped from the aquifer for use by coastal residents and for industrial purposes has caused a drop in the water table, and the Spanish Well no longer flows.
If we were to walk through here and spend some time, we'd find pockets full of pottery, maybe a few arrowheads, plenty of the odd conch shells. It's just evidence of thousands and thousands of years of people camping and living here. There's Deepwater Creek out in front of us, fresh water coming up underneath us. The woods are full of hickory trees and acorns. You know, I can't think of a better place to make a living. There's deer here, there's raccoons, all sorts of small wildlife, birds. And I guess just as today, fresh water is the key to anything living anywhere.
At the end of a long day in the field, it is nice to get together and talk about the day's work and what has been learned. Because we do not have all the answers about how the Indians lived here in the St. Helena marshes, it is natural to speculate about the past and to compare our lifeways to that of the people who lived here when these islands and marshes were being formed. We ride around in boats and get out and pick up a few pieces of pottery here and there and begin to come to have some understanding of how this area developed and where the shoreline was through time. But, you know, we still have long ways to go to come to the understanding you want, because there's, even in archaeology today, there's a lot of disagreement about whether Indians stayed on these coastal islands year-round or they came down here in the spring and maybe the summer and then went inland when it got too hot or too buggy or too cold or whatever reason the people want to give, the archaeologists want to give for their moving. But you and I both know there's no reason to leave once you're here.
How many Indian sites do you think that you and I have documented and uncovered in the last 2 years down here?
Well, we probably visited maybe 50 or so.
That's a lot.
That's a lot, and there's probably hundreds for sure.
Some of them that we haven't found yet,
Yeah.
and some of them that have been already covered over by what you guys are talking about, the change in geology and the rise of sea level.
If the Indians were here year-round, how come we never find any dwelling structures in places like this? I mean, it's not a harsh environment, but it's kind of hard to live here through the winter.
I think down here, despite the fact that there's been a tremendous amount of digging done, I was talking to somebody just the other day, you can barely count a dozen houses that have been found in the last 50 years on the coast.
Indian houses.
Indian houses. But clearly people are living here in large numbers. I mean, there are Indian communities on these islands that cover, in some cases, 100 or 150 acres. And they're large areas of small shell piles scattered about over the landscape, kind of like the ones we saw today when we were at Spanish Well, with separation, so clearly people are living between them, and they have to live in some kind of structures. And I think it's just perhaps we think of structures in a more complex way than the people that were living here did. I mean, maybe you can build a structure with 4 or 5 poles and some palmettos or some skins or something, and
It'll be gone next year.
The preservability of those structures is pretty minor.
If they could so conveniently assemble them, they probably didn't worry that they wouldn't last. What's the difference? Just make another one.
You know, we think about Indians and the way they lived and the kinds of structures they might have needed, and I think we think they needed more than they really did, because all the way up to the time when European trade started, all of the Indians and all of the Southeast, no matter how cold it is, the only clothing they had was really a deerskin draped over their shoulders. No leggings, no tailored clothes, really not even moccasins in the sense that you think about moccasins today. You know, they're very hardy people.
We build $1 million structures with huge foundations and pilings and so on in the same environments that the Indians were building their temporary structures in. And then we have to buy $10,000 worth of insurance every year just to protect them from the hazards that we know are already here.
The Indians that lived on these islands and left all these artifacts and built the shell rings, I think they had a pretty laid-back lifestyle. They didn't have the anxieties. They didn't have the complexity in their lives. I would like to think that, you know, I could get that kind of peace in my life at some point in time. And I get a little piece of it every time I get to come out here. It's hard to get away, but you have to make time for the things that are important.
Well, this is a 10,000-year-old tailor point that Gibbs and I found out on one of the islands there in the marsh. It's distinctive based on its shape and style, the raw material it's made of. And it's one of the oldest points I've ever found in my life, so it's an important piece.
We can come out here and just for little snippets of time, you know, we can be back in time and we can fish on the same shell hills for bass and trout that the Indians did, build our campfires and roast our oysters right on top of their oysters. It does sort of bring you the way back into the present, or the present into the way back, however you want to look at it. One of my favorite things to do is come down here on a cold day like today with my favorite dog, and I go up on one of these little islands and I build a scratch fire with palmettos, and I pick some oysters, and I sit there by that fire in the cold weather against a palmetto tree, and I shuck oysters, one for him and one for me, one for him and one for me. And you know, and I'm throwing them right on top of the Indian's trash pile. So it's my shells on his shells. It's kind of a continuing thing.
We know that there were likely hundreds or perhaps even thousands of Indians living along this part of the coast during various times in the past. We don't find very much in the way of human remains on these islands out here. We know that in some periods they would have had burial mounds, but we haven't found any evidence of those on any of the islands in the St. Helena marshes behind me yet, but there might be some of those. That's one of those questions that hasn't been determined yet, and it's one of the mysteries that perhaps we'll have some opportunity to solve in the future as we continue working out here. The St. Helena marshes have disclosed some of their secrets, but there is still much to be discovered. In the coming years, our continued research will reveal more history that is known to no one, and we will answer questions that have never before been asked. With time, we will better understand the Native Americans who called these marshes home, and we will be able to chart the changes that time and tide have wrought on the landscape. There is some urgency to our endeavors because global warming and rising sea level will flood the marshes and erode the islands and hammocks, erasing some of the record we count on for our work. Once that record is lost, it can never be reconstructed. So when you see a coastal marsh, keep in mind the secrets it contains and the mysteries that can be revealed there, and realize what a fragile landscape it is.